Welcome everybody to Algebra 1, Section 5.5, Parallel and Perpendicular Lines. So let's first define what parallel lines are. We see a picture of it over to the left, and they're not just the horizontal, they can be horizontal, but they might not be. But the definition is that they are lines that never intersect. They will never touch, cross, intersect, whatever word you want to use. And the symbol for parallel lines, to make our life easier at times to write the symbol, is two slashed lines, or it could be two vertical lines. Now, the tough part about the vertical lines is that could be easily misconstrued as an 11, for example, amongst other things in math. And so the two slash lines is more preferred because of that. Now, algebraically, how could we know if two lines are parallel? Let's think about it for a moment here. If two lines are going to be parallel, well, here, for example, we could ask, would these two lines be parallel? And the answer might at first seem, well, yeah, sure, they don't intersect. But eventually, if they continue on, we notice they would intersect, and so they aren't parallel. Because this one goes more up, while this one goes more over. And so in order for them to be more parallel, then, okay, well, what must happen? Well, in order for them to be more parallel, they have to be able to, as they keep going up and right, and as they keep going down and left, still never intersect. And for that to be the case, the only way for that to be the case is for their slopes to be the same. So let me write it this way. They have the same slopes. They have the same exact slope. So for in order for two lines to be parallel, they have the same slope. They must have the same slope, otherwise they can't be parallel. So an example of this would be two equations such as y, it didn't like my y there, I suppose. Y equals 2x plus 1, and y equals 2x plus, or I'll just do a minus just to change it up, minus 7. And both these have a slope of 2. So we don't care that the b's are different. Just the fact that the slopes are the same tells us that, hey, these lines are parallel here. So then we also have perpendicular lines. Perpendicular lines intersect, but they intersect not just in any way. They specifically are lines that intersect or cross or touch or however you want to call it. Oop, I forgot the C, there we go. At 90-degree, which we call right angles. And so algebraically, we have a very special way that we can know that these are going to be perpendicular. And that's if they have what we call opposite reciprocal slopes. And what that means is opposite means opposite sign. So one of them is positive and the other one is negative, so positive slash negative, while reciprocal means that it is flipped as a fraction. And down below it calls them negative reciprocals. It's another term that can be used. I personally just prefer the term opposite reciprocals, but negative reciprocals just tells you that it is the negative version. I think that can be a little misleading because if it starts out, if one is negative, the other must be positive, and so we can think negative of a negative. Sometimes that confuses some of us. But either term is perfectly accurate, opposite reciprocals or negative reciprocals. So some examples, let's find the opposite reciprocal of each of these and the negative reciprocal of each of these. So 3/4, so the opposite reciprocal, that would be negative since the first one is positive, and to be 4/3. So we do the opposite and the reciprocal. So for number 2, we have to first establish that 2 is secretly divided by 1, so thus the opposite reciprocal is negative 1/2. Number 3 here, it starts out negative, so the opposite sign of that is positive, and it would be 8/7. You'll say the negative of a negative is positive. I think 2 negatives in a row becoming positive. 1 is secretly 1/1, and so reciprocal of that is negative 1/1, which is just secretly negative 1. And 5, 0, that's kind of a tricky one. We'll think of it this way. It's technically 0 divided by a number, and so the reciprocal is a number divided by 0. And any number divided by 0 we know is actually undefined. which we can abbreviate to U and D. And remember that a slope of 0 means that it's a horizontal line, and an undefined slope means that it's a vertical line, and that's because any horizontal and vertical lines are perpendicular with each other. They intersect with each other at right angles. So we're supposed to determine if the two segments are parallel, perpendicular, or neither. And so how you would tell is you find the slope of each segment or line, essentially here. We're not quite familiar with the term segment yet since we haven't had geometry, but this is just saying segment AB, which is just a portion of a line, essentially. We're supposed to see if the segments or lines are parallel, perpendicular, neither. And once again, how we would know is by finding the slopes of each. So if we find the slope of the first one, find the slope of the second one, we then compare the slopes. If the slopes are the same, they'd be parallel. If the slopes are opposite reciprocals, they're perpendicular. And if it's literally any other combination, so if they're different in any way that is not opposite reciprocals, the lines are neither parallel nor perpendicular. They just intersect in a non-special manner, a non-right angle. And so as we find the slope of this first one here, so the slope, and this will be for AB, I'll do in orange, I'll circle that there so we know. I'm going to do 6 minus 3 using the slope formula, y2 minus y1 over x2 minus x1 over 2 minus a negative 2. And so that's going to give me 3 over, add those and get 4. And so then I find the slope of my other one, which I'll do in blue, and I'll just show that to match the colors. And I'll do 3 minus 0 over 3 minus negative 1. And so that ends up giving me two positives, and I get 3 over 4. And we notice, hey, these slopes are the exact same, and thus these lines are parallel, which you could write out, or you can do the symbol, which I'm lazy, so I'm going to choose to do the symbol. On number 2 here, I'm going to do the first one in orange again. I'm just going to continually do that. The slope of this would be 4 minus 2 over 5 minus 0, which is really just 2 over 5. And now as I do the other one in blue, I'll have 8 minus 3 over 1 minus 3, which is 5 over negative 2. And so you notice that these are reciprocals and they're opposite signs. One is positive, one is negative, so thus they are perpendicular. Now I forgot to mention the symbol for perpendicular is like an upside down T. I should go back up and mention that real quick here. That the symbol for perpendicular is this upside down T, and the reason that's the symbol for perpendicular is if I were to continue this, they look like mini perpendicular lines that intersect at right angles. But I can't do this symbol because that can be easily misconstrued as a plus sign in math. And I can't just do the top half of the T, or the bottom half of these perpendicular lines, because that looks like a T. And so we do an upside down T, which looks like nothing else in math. You could also write out the word perpendicular or put PERP, period, as an abbreviation. On number 3, once again, sticking with my theme of doing the top one in the orange, I'm going to do the slope is 8 minus 6 over negative 1 minus 2. And that's going to give me 2 over negative 3. Finding the slope of my other one, I would end up having 3 minus 2 over 3 minus a negative 1. I add those on the bottom, and I end up getting 1 over 4. We notice that these slopes are not the same, and they're not opposite reciprocals, so these lines are neither parallel nor perpendicular. Next here, we're going to once again do the top one in the orange, and this will be a slope formula of 4 minus 3 over negative 1. Maybe clarify that negative, there we go, minus 2. And that's going to be 1 over negative 3. Once again, where the negative is on a fraction doesn't even matter a little bit. As I find the slope of the other one in blue, I'm going to have 6 minus 3 in the top over negative 4 minus a negative 5. Bottom. Two negatives are on the bottom, make it positive. And I'm going to have slope equals 3 over 1, noticing that these are opposite reciprocals of each other. One is positive, one is negative, and they are reciprocals flipped. So these lines are parallel. Moving on to the next page here. We're going to continue on. Once again, I'll do the orange for the top one. So the slope for the top one, we end up having 7 minus a negative 2 over 0 minus 0. Well, that means we're going to have 7 plus 2, excuse me, and that's going to be 9 over 0, and that is undefined. That's a vertical line. So in my other one, I'd end up having negative 5 minus a negative 5 over maybe 6 minus 3, which those add on the top, and I get 0 over 3, and 0 divided by anything is 0. And as we talked about earlier, the opposite reciprocal of undefined is 0, and vice versa. And the reason why we don't have to worry about signs being different is because, well, 1, this isn't a number, so it can't have a sign, and 0 can't have positive or negative. It's neither positive nor negative. And we talked about how this one's a vertical line, and this one's a horizontal line, thus making them perpendicular. And 0 over a number compared to a number divided by 0, reciprocals. Even if the number wasn't technically the same, doesn't matter. Number 6. Finding the slope of the first one, I end up having 7 minus 6. Finding the slope of the x values, the difference of the y values, I will write, try that again, a negative 4 minus a negative 2. So I end up having 1 over negative 2 as I add those. Finding the slope of the bottom one here, I end up having 3 minus a negative 2 over negative 8 minus 2. And so the top I add, and I get 5 over negative 10, which reduces to negative 1/2. Once again, where the negative is doesn't matter, so if let's say I put the negative on the top in this fraction, on the bottom of the fraction, they're still both negative. And since they're the negative and they're the same, they're parallel. Now, if one of those had been a positive, then these wouldn't be parallel, they'd be neither, because it'd be opposites, but not reciprocals, and they're not the same. Number 7 here, finding the slope of this first one in orange, I'm going to have 1 minus a negative 4 on the top, and on the bottom a 3 minus 3. Some of us may already catch what's going on here, then I'm going to have 5 over 0, and the 0 is the important part there, because this is going to be undefined or a vertical line. Finding the slope of my other one here, I'm going to have 5 minus 1, and on the bottom I'll have negative 4 minus a negative 4, which some of us might also see what's going on here as I add those, and I get 4 over 0, which is also undefined. And so thus, since both slopes are undefined, they're both vertical lines, they will be parallel. On the number 8, finding the slope of this one, I will end up getting 8 minus 2 over negative 3 minus 3. That will not give me 0 in my denominator. I will end up getting 6 over negative 6, which is negative 1. Finding the slope of the other line, I end up getting m equals 1 minus negative 1 on the top, and the bottom I'll do 7 minus 5. On the top they add, and I get 2 over 2, which is really 1. And as we mentioned before, these are opposite reciprocals, because this is over 1 and this is over 1. So they are reciprocals of each other, and they're opposite signs, so these lines are perpendicular. Now, once we're moving on from to problem 9, we're now doing a different thing, where we're given the equation. So rather than given points, we're given the equation, and then asked to find the slope of each, so that way we can compare them. So this first equation here, which I'll continue to do in orange and blue, has a slope of 7. We can tell because it already has y by itself. It's y equals mx plus b, and so it fits where the m would go in y equals mx plus b by being multiplied with the x. And the second equation has the same idea, where it's slope-intercept form already, and so the slope is 7. These are the same slope, so the lines are parallel. On number 10 here, they are both in slope-intercept form again, so the slope on number 10 is 4/5 for the first equation. The second equation has a slope of negative 5 over 4. These are opposite reciprocals of each other, and so they are perpendicular. On number 11, these are both in slope-intercept form again, and so the slope of the first one is negative 1/3. The slope of that second one is positive 1/3. They're opposite signs, but they're not reciprocals, so they're neither parallel nor perpendicular. Number 12, we start having to solve these to get them in slope-intercept form. So on this first one here, I'll subtract it by x, and I'll get 6y equals negative x plus 30. I divide every single thing by 6, and I get y equals negative 1 over 6x plus 5. This tells me my slope is negative 1/6. Didn't really need the plus 5 for this problem, because I don't need to graph it or anything like that. I'm just comparing the slopes. So for my other one, I divide everything by 3 to get y by itself, because y is being multiplied, and I get y equals 6x minus 1, meaning my slope is 6, or 6 over 1. Remembering that 6 is really the same thing as 6 over 1 helps us remember that these are perpendicular then, or helps us identify that they are opposite signs and reciprocals. On to number 13, once again needing to solve the first one, but not needing to solve the second one this time. So I solve the first one by subtracting 5x, and I get negative y, making sure I take that negative with y, equals negative 5x plus 4. Now I divide everything by a negative 1, and I end up getting y equals positive 5x minus 4, so my slope is positive 5. My other equation already is solved, so my slope is negative 1/5. These are opposite reciprocals because 5 is secretly divided by 1. Thus, these lines are perpendicular. On number 14 here, I had to solve both equations for y, so I solved the first one by subtracting 3x. Negative y equals negative 3x plus 2. Divide everything by negative 1 to get y by itself. And I get y equals 3x minus 2, so my slope is 3, or 3 over 1. My other one, I subtracted 12x. And I get negative 4y equals negative 12x plus 4. Divide everything by negative 4. Y equals 3x minus 1. So my slope here is also 3. Thus, these are parallel because the slopes are the exact same. So now if we look at number 15 here, and I start finding the slope, both of these are in slope-intercept form already. What a convenience. So the slope of this first one is 1, or 1 over 1. The slope of the second one is negative 1, or negative 1 over 1. These are opposite reciprocals of each other. Thus, they are perpendicular. Now we have number 16, and so here, y equals 6. We've got to remember that this is simply a 0x plus 6, but also remembering that a y equals 6 is really a horizontal line, which means it has a slope of 0. X equals negative 1. No tricks here to find the slope except for just knowing that x equals a number is a vertical line, and thus has an undefined slope. Oop, I meant to pick blue there. And as we mentioned before, vertical and horizontal lines, or slopes of 0 and slopes of undefined, are opposite reciprocals of each other, and thus the lines are perpendicular. Moving on to the next page here, we're going to write equations of parallel perpendicular lines. So we spent a lot of time identifying whether lines are parallel or perpendicular. And so what are we doing? We're going to be given a linear equation and a certain point. And then you're going to be creating another equation that passes through that point and is either parallel or perpendicular to a given line. So we're going to be given a line, given an equation of that the line is for or of, and then we're going to be taking that equation and using the slope to make a new equation with a point. Because remember, if we have a point and a slope, we can use point-slope form, which we learned in section 5.4. So a quick reminder from earlier this lesson that parallel lines have the same slope, or same slopes, and perpendicular lines have what we call opposite reciprocals, or negative reciprocals. And opposite, remember, is the opposite sign, which is positive versus negative. And reciprocals means that you just flip it. So on number 1, we're supposed to write the equation, clarifying that number 1 and number 2 are for parallel lines. Number 1, we're supposed to write the equation of the line that passes through this point, negative 2 comma 7. So that's going to be our x1 and y1. And is parallel to this line, y equals negative 4x plus 1. Well, in order to write our equation in slope-intercept form, we need to first have a slope. And we don't have a slope. However, we are told it's parallel to this line, and remember that parallel lines have the same slopes. So if we were to know the slope of this line, we could say, oh, it would be the same as the slope for our new line that we actually want. And we do know the slope of this line because y is by itself. And so the slope of this line is -4. That means the slope of our parallel line, which I'm going to do a little parallel symbol underneath my slope to show that it's a slope of the line parallel to that line that we're given, the equation, would also be -4. So I'm going to take that new slope of -4, which is the same as the old slope of -4, and use this point to put it in point slope form. So I have y minus 7 is equal to -4 times the quantity of x minus -2. Now you may notice that we didn't even use this +1 at all. And we never will on these types of problems, because when we're identifying parallel and perpendicular lines and making parallel and perpendicular lines, we don't care about the y-intercept, we only care about the slope. That's what we did over here, as I was mentioning, hey, it's like, we don't care about this number, or this number, or this number, or this number, or down here on like this problem, I said we didn't care about the 5, and we didn't even a little bit. So now as we continue this equation here, this point slope form, to turn it into slope intercept form, I say two negatives make a positive, and I get y minus 7 equals, I distribute my -4, and I get -4x minus 8. I then will add 7 to both sides of the equation, and I get y equals -4x minus 1. So on number 2 here, we're writing the equation of a line that passed through the point 3, -1 is parallel to this new line, x minus 3y equals 9. And we notice this one, the slope is not easily identifiable because y is not by itself. It's not in slope-intercept form. So we first have to get it in slope-intercept form, and then we can identify the slope and use the slope with this point in point-slope form. So we have to work to get that, and so let's subtract x here to get this in slope-intercept form to get y equal to everything else. And we get -3y equals -x plus 9. Then I divide every single thing by -3. And I get y to equal 1/3 x minus 3. And I really could not care less what this b is here, because I'm only looking for the slope of 1/3. So that way I can use the slope of the parallel line, which would also be 1/3, because parallel lines have the same slope. Now I can disregard the rest of this equation and just use this slope and this point and plug that into point slope form. And so I'm going to have y minus y1 equals m times the quantity of x minus x1. And I start distributing from here. But I do take into account these two negatives make a positive, and so I have y plus 1 equals 1/3 x minus 1. And then I subtract 1, and I get y equals 1/3 x minus 2, and we successfully made an equation of line that is parallel to this line, same slope, but goes through this point 3, -1. On number 3 here, we're going to write the equation line that passes through this point, 4, 3, and is now perpendicular to this line. So once again, we need the slope. We need a slope, the slope of the line, in order to get point slope form. And so we need the slope of this line. And the slope of this line is 2/1. We can easily identify that since it is in slope-intercept form, y equals mx plus b. However, we're not doing parallel slope anymore, the slope of a parallel line, we're doing a slope of a perpendicular line. And that's not going to be the same, it's going to be the opposite reciprocal. So in this case, it'll be -1/2. And so we have to use the slope of -1/2 here. Once again, could not care less about the b, the y-intercept of that line. We're going to use -1/2 and this point to plug it in point slope form. So y minus 3 is equal to -1/2 times x minus 4. And I go ahead and start distributing, and I get y minus 3 equals -1/2 x plus 2. And as I go ahead and add 3 to both sides, I get y equals -1/2 x plus 5. So very similar to how we did parallel lines, except for when we find the slope, we'd make it the opposite reciprocal slope and use that. So here on number 4, I have to find the slope of this line, so then I can use the opposite reciprocal slope. But in order to find the slope of this line, I need to get it in slope-intercept form, y equals mx plus b. So I'll start by subtracting 5x from each side, and I end up getting 3y equals negative 5x minus 21. I divide everything by 3 here, and I get y to equal negative 5/3 x minus 7. Once again, the minus 7 is of zero concern to me. I do need to identify that the slope is negative 5/3. That way I can identify the slope of the perpendicular line. And that would be positive 3/5. And that is the slope I will be using. So now I use that slope along with this point, and I plug it into point slope form. And I get y minus 1, is equal to 3/5 times x minus a negative 5. Acknowledging that two negatives make a positive in a row, I get y minus 1 equals 3/5 x. And as I multiply 3/5 times positive 5, I end up getting positive 3. And so now I add 1 to each side, and I get y equals 3/5 x plus 4. On to the next page, we have some more examples. Which literally says more practice. So we have 4. We're going to be doing parallel lines, lines parallel to a given equation going through a point, and then 4 more that are perpendicular. So on number 5, we need to use the same slope as this one here. The current slope is 2, or 2/1, so the slope of our parallel line will be also 2. And so we plug this into our slope-intercept form. Y minus a negative 1 is equal to 2 times the quantity of x minus a negative 4. Two negatives in a row make a positive, and I get y plus 1 equals 2x plus 8 as I distribute 2. And that gives me the one, either I didn't write it or it didn't write, I'm not sure which, but I'm going to go ahead and subtract 1 on each side now, and get y equals 2x plus 7 as my answer. On number 6 here, the slope of this current line is negative 1/4 rather, and the slope of our line parallel to that would be the exact same, negative 1/4. And so now as I plug this in, I get y minus 3 is equal to negative 1/4 times x minus 8. So that's y minus 3 equals negative 1/4 x plus 2 as I distribute the negative 1/4. And so if I add 3 to both sides, I get y equals negative 1/4 x plus 5. On number 7, I need to get the equation in slope-intercept form first, so I'm going to go ahead and work through that by subtracting x and getting negative 2y equals negative x plus 14. I move my work a little bit over to the left so that way I can have room to do my slope-intercept or my point slope form once I get the slope. Dividing everything by negative 2, I get y equals positive 1/2 x minus 7. The minus 7 doesn't even matter a little bit, but the slope of this line is 1/2, and the slope of my parallel line then is also 1/2. And so I take that slope, I take the point, and I plug it in. And so I'll have y minus 5 is equal to 1/2 times the quantity of x minus 4. And so that's y minus 5 equals 1/2 x minus 2 as I distribute the 1/2. I add 5 to both sides, and I get y equals 1/2 x plus 3. On number 8, once again, need to find the slope of this line by getting in slope-intercept form. So I'll subtract 5x and again move my equation to the left so I have some room. And I'm going to have 2y equals negative 5x plus 10, dividing everything by 2. And I get y equals negative 5/2x plus 5, telling me that my slope of this line is negative 5/2. Knowing that the slopes of parallel lines are the same, the slope of my parallel line will be negative 5/2 as well. Plugging this in, I get y minus 7 is equal to negative 5 over 2 times x minus a negative 6. So I get two positives there, and I distribute my negative 5 halves, and I get y minus 7 equals negative 5 halves x minus 15. And then I go ahead and add 7 here, and I get y equals negative 5 halves x minus 8. Now on number 9 here, 9 through 12 I should say, these are now going to be perpendicular, which is bold and capitalized to really help drive the point home. So the slope of this line here is 3/4. We're just given that since it's in slope-intercept form, meaning the slope of our perpendicular line is going to be negative 4 over 3. So I go ahead and plug this into point slope form, and I get y minus a negative 3 is equal to negative 4/3 times x minus 3. I go ahead and make those adding, and I distribute my negative 4/3, and I get y plus 3 equals negative 4/3 x plus 4. Subtract 3, and I get y equals negative 4/3 x plus 1. Then I look at number 10 here, and I see my slope of this line will be 1, meaning the slope of my perpendicular line, I almost said parallel, is negative 1. Plug this in, I get y minus a negative 2 is equal to negative 1 times x minus a negative 3. And so I have positives there on both of those, and I get y plus 2 equals negative x minus 3 as I distribute a negative 1 in. I now subtract by 2, and I get y equals negative x minus 5. On to number 11 here, finding the perpendicular line that goes to this equation that goes to the point 2, 3. So we first find the slope. We'll start by subtracting 2x so we can get this in slope-intercept form. And I'm going to move my equation left just like I did up above on problems 7 and 8. So I'm going to get 10y equals negative 2x plus 20. Divide every single thing by 10. I'm going to get y equals negative 1 over 5x plus 2. So that tells me my slope is negative 1 over 5, which means the slope of the line perpendicular to that would be 5 or 5 over 1, and it'd be positive. So now I'm going to plug this in. I'm going to get y minus 3 is equal to 5 times the quantity of x minus 2. So I have y minus 3 equals 5x minus 10 as I distribute the 5. And then I add 3 to both sides, and I get y equals 5x minus 7. On the number 12 here, I solve this equation for y by starting with subtracting by x on each side. There we go, eventually got it. And I get 3y equals negative x plus 6. So I'll divide all 3 parts by 3. And that gives me y equals negative 1/3 x plus 2, which tells me that the slope of this line is negative 1/3. So the slope of my line that will be perpendicular to it would be a positive 3 over 1, aka the opposite reciprocal of negative 1/3. And so I plug this in and I get y minus a negative 6 is equal to 3 times the quantity of x minus a negative 1. And then from there, I go ahead and say those two negatives make a positive when they're in a row, and I get y plus 6 equals 3x plus 3. And then I will go ahead and subtract 6 from both sides, and I get y equals 3x minus 3. I emphasize that this was an equal sign in the purple there. The second line didn't draw very well. So then my answer is y equals 3x minus 3. And that wraps up section 5.5 of Algebra 1.